we've also got, whilst we're looking at pollution, you've got the plastics question, that when you go to the centre of the circulatory motion currents in the various oceans, what are known as the gyres, you will find this large concentration of plastic. And it's estimated about 8 million tonnes of plastic is being put into the ocean every year. I don't know whether that figure's all right or not, but even if it's got a substantial margin of error, you can appreciate the vast size. Now, one of the interesting figures that I saw only yesterday, actually, in reading the newspaper, was that of that 8 million that's going into the sea, 700,000 tonnes is fish nets. So when you've got these large fishing vessels operating in the high seas, deploying nets, which for one reason or another they lose, they are being lost and not recovered. That has, the consequence of forming, as you can see, about 1/10 of all the plastic that's being added to the ocean each year. And because of the nature of the net, it traps a lot of other marine creatures in them who drown as a consequence or are unable to escape and starve. So there's that dimension to it as well. There are various estimates that if we go on using and releasing plastic in the same way as we are at the moment, the weight of plastic in the ocean by 2050 will be equal to the weight of all the fish. I don't quite know how that calculation's been made. Presumably you can weigh the plastic up on one hand and estimate the weight of the fish stocks on the other, but that prediction has been made. It's illustrative, I think, rather than factual, of the trend in which we're going. So we have to think also as a society globally as to what is causing that. And then you've got other issues of pollution besides, and I haven't got time really to go into a great deal of those. But one of them in our seas that has a great deal of impact is marine aggregate dredging, which I have to bring to your attention because it's one of the areas where Marinet does a lot of work. One of the problems in this country is where do you source the sand and gravel that you use for the construction industry, which is one of the basic ingredients of making concrete. And either you've got to go to a land-based quarry, or you've got to actually produce the gravel and break up the rock. Now, many people don't like quarries near them, so the industry has been allowed by government to go offshore and to actually hoover up the seabed. Now, gravel beds are prime habitat for fish. That's where fish like to spawn. And so dredging a gravel bed has very serious consequences in terms of impact on marine life. And if you take London, for example, virtually 100% of the sand and gravel that is being used by the construction industry to build in London today is coming from the seabed around the UK. In the English Channel, off the Thames estuary, and along the East Anglian coast. So it's a major industry with a major impact, and Marinet has been focusing on that, particularly most recently in the case of the Goodwin Sands, which lie just after Dover, because the Dover Harbour Board has wanted to dredge the Goodwin Sands for sand in a port redevelopment scheme, and that's a potential marine conservation zone for a number of different reasons. But nevertheless, the licensing agency, the Marine Management Organisation, part of government, has just given a licence to dredge the Goodwin sands. And the one other fact that I draws your attention, is another report that was in the paper yesterday. Fukushima. Fukushima is. Pardon?
Well, nuclear reactor.
Yeah, the nuclear reactor in Japan that got destroyed by the tsunami when they had an earthquake offshore. Just when I say nuclear reactor, they actually had 3 or 4 nuclear vessels there. Now, one of the problems there is that nuclear power stations, I don't know whether you know much about them, but nuclear power stations require cooling water constantly to stop them exploding. And if you don't cool them down, they do explode, which is what happened at Fukushima, because the tidal wave came, blew all the electricity, pumps failed, and the whole thing blew up. Now, in order to keep the remnants of Fukushima under control, they've had to artificially control, to irrigate the remaining reactors and the radioactive material that's there. And they've been storing that in large tanks on site in the hope that the cleaning up technology that they use at a place like Sellafield, up on the Cumbrian coast, can remove the radioactive material out of the water and thus allow them to discharge that cooling water into the sea. But it turns out that the technology that they've been using hasn't worked. And so they've left with all their tank capacity is now virtually full up. And the radioactive contamination, strontium, iodine, radionuclides in particular, is still present. And they are confronted by the problem, what do we do with this water? And they're currently seeking permission from the government to discharge it into the ocean. So you've got pressures, which is that's one example of pollution going on all around. And these are the things that we, as a civilization, as a global civilization, have got to address if the health of the oceans is going to be maintained and we don't end up in that 2050 scenario. Now, the last thing I want to just bring to your attention is these marine protected areas. What kind of management would actually be deployed if you were a manager of a marine protected area? What would you say to yourself? What are my objectives here? How do I go about this? What am I actually managing?
So you're managing the things that could be detrimental to the environment. So if it's a specific protected area, you'd have no fishing, you would have no harvesting of anything from the area, clean environment, have it cleaned frequently, minimal pollutants, so of course inevitably we're always going to have pollutants from everywhere, and just helping promote the area or the ecosystem of its required nutrients and enabling them to stay secure.
Yeah, that's an interesting idea. Help the ecosystem. You've given us a suggestion, and this is putting my sort of finger on this precise point, which may seem a bit obscure to you, but the point I'm trying to make is that you cannot manage the oceans. They're the natural world, full of many species, most of which we've absolutely no clue about, let alone knowing how they breed and sustain themselves. So you can't manage the natural world. So when you create a marine protected area, it's not the natural world that you're managing. It's the human activity and its impact on the natural world that you are managing. And that's the vital distinction in what a marine protected area is doing. Managing the human activity so that what we do does not damage the integrity of that ecosystem, of the natural world. So you have an idea the principles of the way in which that ecosystem operates, which will be imperfect because our knowledge is limited, but it's the actual human activity that marine protected areas have to concentrate on. Now, the difficulty with marine protected areas is the management regime of human activity that is set up. And when you study the subject, you find that the term marine protected area varies in whichever part of the world, which countries made it, and it's a very broad definition altogether as to what constitutes it. But the idea of conservation is the primary one. But as you can see, even in the United Kingdom, where we've set up our own version of the marine conservation zones, we are allowing human activity inside a marine conservation zone, such as Goodwin Sands, which is going to be damaging to the integrity of that ecosystem. So we've set up a management concept of, which in many ways you might describe as feeble. There is no actual management body. There is no group of people who come together regularly to discuss how to manage the human activity. The best you get is licensing it, and that's it. And even when they've got a licensing control, it's still allowing things to happen which impact on it. And you'll find that there's 50-odd marine conservation zones around the country, and it would be an interesting project if you have time to do it, to see what kind of human activity is actually allowed in our own, in the UK, marine conservation zones. And one of them is fishing. Most marine conservation zones are fished. Most marine conservation zones will get an aggregate dredging license if it's applied for. So marine protected areas is the direction that we've got to travel. And the concluding idea that I'm going to leave you before we look at the films is that one of the pieces of work being done by a Marinet member, which is called Conserving the Great Blue, is to set up at a global level a management system of human activity, a licensed management activity that covers the whole spectrum of human activity. Now that may seem a highly utopian, idealistic attempt, and it is. But we do believe that the 2050 scenario that we've made the film about is a very real danger. And the only way we can guarantee avoiding it is to set up a management system of the way in which we use the ocean, which is 100% responsible. We've got a climate treaty in the Montreal Protocol, which deals with the substances that destroy ozone in the atmosphere, the ozone problem. Now, the Montreal Protocol has managed to get a grip on that, and that's a global treaty on what is allowed to be emitted into the atmosphere. We've got a struggling global effort to control carbon dioxide. We need to also have a strategy for managing the oceans, and a further pillar in this global management of the way in which we live on this planet. And that's where we, Marinet, are focused, bringing in the pillar into this management for affecting the ocean.